Okay, so number one, it says the following four statements are taken from the notebook of a student who completed section 1.1, heating of baking soda. I observed drops of a liquid near the top of the tube. Gas is collecting in an inverted bottle. The gas came from the baking soda. The droplets came from the baking soda. Which statements are based only on what was learned in section 1.1? That should be all of those things. Okay, you saw all of those things in section 1.1. Number two, a group of 100 identical marbles with a total mass of 125 grams were poured into a graduated cylinder and found to come up to the 100 cubic centimeter mark. When the marbles are added to 75 cubic centimeters of water, in a second graduated cylinder, the water level rose to the 137 cubic centimeter mark. What's the volume of the marbles alone in cubic centimeters? You have to take 137 minus 75 and you get 62. Same thing, same statement. They want to know now what the mass of the marbles is in grams. We've got 100 of them, and they have a mass of, I need to do some editing there, 125. So 125 divided by 100 gives you 1.25 per marble. Question 4, an amount of gravel was placed in a graduated cylinder and found to come up to the 40 cubic centimeter mark when the gravel was added to 60 cubic centimeters of water. In the second graduated cylinder, the water level rose to 85. What was the volume of the air in the gravel in the first graduated cylinder? So you're going to have to do a little bit of I guess upper level math here. To find the volume of just the gravel, you're going to take 85 minus 60, right? Which is 25. So that's the volume of just the gravel. We thought we had 40. So if we take 40 minus 25, that's going to give you airspace, which is 15. So that should be your answer there, 15. I had a lot of people put 25 on this because they just didn't go far enough, I think, is why. Number 5 says a graduated cylinder contains 30 cubic centimeters of water. When glass marble X was dropped into the water level rose to 32.5 cubic centimeters. A second graduated cylinder contains 25 cubic centimeters of alcohol. When glass marble Y was dropped into it, the level of the alcohol rose to 28.5. Did these data enable you to compare the volumes of the two marbles? That should be yes. Marble X is less than the volume of marble Y. Doesn't matter if we use water or rubbing alcohol, it's going to take up the same amount of space in both of them. A graduated cylinder contains water to the 15 cubic centimeter level. A stone was placed in the water, which rose to 21. Then a cork stopper with the same stone resting on it so it can hold both submerged was placed in the water and water level rose to 26. What's the volume of the cork stopper? Well, it's going to be the volume of the stone and water, which is 21 minus 26, which is 5. Number 7, 1,000 unit cubes were stacked 4 different ways to form shapes with the dimensions given below. Measured in unit cube lengths. What are the dimensions of the shape? The shape with the largest volume. It tells you we use 1,000 unit cubes, so these are all 1,000. But if you do the math here, you get 1,000 for all of them. So the answer is all the shapes have the same volume. Number 8, where did the droplets on the test tube come from in heating baking soda? That was the baking soda. Number 9, a milliliter is the same as, oops, that's wrong, a cubic centimeter. Number 10, which of the following would be the best way to determine the volume of sand? Determine the amount of water displaced by the sand. This one right here. What's the Troping balance used to measure? That's mass. Which of the following is the proper technique for lighting a microburner? You open the main valve, light the match, open the burner valve, and then light it. And then what's the proper way to turn it off? You turn off the main valve and you turn off the burner valve. As far as eye protection goes, you use eye protection anytime chemicals or heat or glassware are used in the lab. 15 and 16 are over the scales up here at the top. That some of you couldn't get to pull up yesterday, but 15, it's about reading a graduated cylinder. It's kind of hard to see, but this is 20, this is 30, and then there's a mark here, 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 and here. These marks in between are 2s, so 22, 24, 26, 28. If you look at it, the meniscus is in between 22 and 24. It's actually probably a little closer to 24, but we only measured the nearest half unit, so we would call this 23. All right? And then the next one, I think it was 16, is over at this measurement here. We always estimate one place beyond what the scale gives us. The scale gives us the tenths, so we need to go to the hundredths. The only choice that goes to the hundredths is 16.33. which should be the answer to that one. So let me go back down to, yeah, 16.33. 17, what are the two main branches of science? They're physics and chemistry. Number 18, in a graph showing how the temperature of a material changes over time, temperature change is the dependent variable. A factor that changes an experiment from the manipulation of the independent variable is the dependent variable. A unit of measurement that's obtained by combining other units is a derived unit. A testable prediction is a hypothesis. A standard is an exact quantity people agree to use for comparison. Number 23, in experiments to determine if the popping of popcorn is affected by the temperature at which it's stored. Counting the pop kernels is an example of an observation. Number 24, an idea, structure, or system that can be used to represent something you're trying to explain is a model. Number 25, a rule or principle that describes the behavior of something in nature is a law. Number 26, why is it important to make measurements using a standard? This is 2 points, give you 1 point for trying, 1 point for the answer. The reason why we use a standard is so that everybody knows the exact quantity that we mean. All right? It has nothing to do, I had some people say, so that everybody uses the same measurement. That's not why. You can measure something in meters, you can measure something in centimeters, but the standard for comparison is the same. Okay? We know that a meter is 100 centimeters. Okay? And a meter is whatever, this long. Always. It doesn't change. It's not based on somebody's foot or somebody's arm length or whatever. Okay? Number 27 says a family wants to test the effectiveness of a misting shower head in conserving water. They place a large tube at the bottom, that needs to be fixed, of the shower. With the old shower head in place, they turn the shower on full force for 1 minute. They then replace the shower head with the new misting shower head and repeat the procedure. What's the independent variable? Well, it's the type of, or the shower head that we're using. That's what we're changing, right? That's what the experimenter is changing. Then the same statement says, what's the dependent variable? It's the amount of water. What's the control? It's the old shower head. That's what we're comparing it to. What's a constant? Time is constant. All the following are standard components of the experimental process except for opinions. All the following quantities have derived units in the SI system except for mass. Mass is a base unit and has a standard to back it up. It's not derived. Write 87,000 in scientific notation. Well, it's going to be 8.7. And we're going to move the decimal point 1, 2, 3, 4 places. So times 10 to the fourth. Since we go to the left, it's the fourth, but not the negative fourth. Okay? Number 34. Write 1.25 times 10 to the sixth in long form. So I'm going to say 1.25. We're going to move the decimal point 6 times. So 1, 2, 3, 4, 5, 6. So it's just going to be, what is that? 1.25, well, 1,250,000. Okay? Number 35, which of the following is the best application of a line graph? This one right here, to show trends and how the data changes over time. Any questions about that? So I'm going to open it up again, and you can retake it sometime. I'll probably give you about a week to retake it. You have to do it on your own time, okay? Fair enough?
Will you take the high score?
I'll take the